Hello everyone. Since it's a early morning at my place and I have finished my breakfast with two pieces of bread and one slice of cheese, I thought let me teach you stoichiometry with a real life example which would be much more interesting than starting with the presentation at first. So let's see a very quick example which is the most easiest example that you can ever relate with. So let's see that in the first example they have showed you two pieces of bread and one slice of cheese, which gives you two pieces of bread and in between you can see one slice of cheese. Now, how many slices of bread do you need to make 7 grilled cheese sandwiches? As we all know that we all love cheese sandwiches, then how can we make it with only some slices of bread? So let's see. Now, since I need 7 grilled cheese sandwiches, so I will multiply it with 2 pieces of bread and divide it with 1 grilled sandwich, which equals to, that means 7 into 2 will give you 14 pieces of bread. The balanced equation is our conversion factor. Now, what is exactly balanced of equation? We really don't know. So let's see what the next slide says. Now the next slide says that what is a chemical reaction? To know what is a balanced equation, we should know what is a chemical reaction. If you all are going to decide that you all are going to take chemistry for your future life, then knowing what chemical reaction, knowing what stoichiometry and knowing what is a balanced equation is very mandatory. So let's see what is chemical reaction. What is a chemical reaction? A chemical reaction is a process in which some substances undergo bond breaking and are transformed into new substances by formation of new bonds. The substances taking part in chemical reaction are called reactants, whereas the substances formed as a result of a chemical reaction by formation of new bonds are called products. Let's see it with the example which is given below. You can see there are some alphabets written like A, B, C and then A and BC. Now what exactly does this mean? You can see a AB, right? Now what is that AB called? That AB is called as a molecule. When a molecule is added with an atom, this is the left hand side of the reaction which is called as your reactants. That is what is being explained in the first 3 lines. And then they have told that the right hand side of the arrow which is in the between will give you one atom which is added to a molecule. Now here the molecule is BC. So when there are left hand side products and which is reacted and then gives you a right hand side products, it actually means that there is a formation of new bonds which is called as a products. Easy? Now let's go to the next example. Oxidation and reduction are a few types of chemical reaction. Now let's see what are the few types of reaction, that is oxidation and reduction. To learn what exactly oxidation and reduction is, now there are few examples that you can consider. The first example is burning of methane to give carbon dioxide and water vapors. Second example is hydrogen gas and oxygen gas gives liquid water. You can see there are certain example that is in the geometrical representation which is given below, which is methane when it is added to oxygen, it gives you carbon dioxide and water. So let's see the numerical explanation of this, that is CH4 plus 2O2 which gives you CO2 which is added to 2 molecules of water. Now, what is a chemical equation? Now exactly to understand what a chemical equation, we have represented it with the example. Over here the example is sodium ion is added to chlorine ion which gives you NaCl. A simple way of writing a chemical reaction using chemical formulae of the reactants and products is called a chemical equation. How to write a chemical equation? Now the most important topic over here is to write a chemical equation. So to write a chemical equation, you have certain conventions, that are certain steps that you have to follow to write a chemical equation. To understand this, let's understand this by an example. Examples are one of the most easiest way to understand any topic. So here also we have given you an example, which is 2H2O plus O2, which is indicated by an arrow that it is indicating that the reaction is forming a new product, which is 2H2O. Now here your H2 is a reactant. You have taken 2 atoms of reactant and you have added it with 2 atoms of oxygen, which gives you a molecule, which gives you 2 molecules basically of water. So a chemical equation is basically that contains reactants and the products and an arrow indicating the direction of the reaction. Now here the point to be noted is that your arrow is indicating what your direction is of the reaction, whether it is going forward or whether it is going backward. So here you can clearly see that your reaction is going forward. That means the formation of new bonds of products is being shown. The reactants are written on the left hand side while the products are on the right hand side, which is very easy, and I have told you twice and thrice that the left hand side is called as the reactants and the right hand side is called as the products. You all can make some bullet points to understand what left hand side is and what your right hand side is. Now your left hand side is reactants, your right hand side is products. What we are learning, make the short notes of it, which will help you all to make a revision notes before your exam. Okay, now let's go to the next slide. If the reactants or products are 2 or more, they are linked with the plus sign which is in the between. As I told, when there are 2 reactants, to understand that it is added, a plus sign is shown. So a plus sign basically indicates the linking of 2 reactants or 2 products. Here also they have given you an example, which is HCl plus NaOH, that gives you NaCl plus H2O. Now here hydrochloric acid when added with sodium hydroxide gives sodium chloride and water. If you are studying for the exam, you need to know both the chemical representation as well as what are the names of the reactants and products, because in every example, whenever you are writing in the exam, you have to write the statement, that is the names of the products and reaction and the chemical formula of the reactants and products. So please make a note of it. Next slide. A chemical equation is also required to indicate the physical states of the reactants and products that participate in the reaction. Now for example, you have an example of here to understand that you have a zinc, okay, and it is added to H2SO4. Okay, fine, that much I understood. Now it is forming a new bond, which is showing that the arrow is in the right side. That is, there is a forward reaction, and that forward reaction is forming 2 new bonds, that is 2 new products, which is ZnSO4 and H2. Okay, now this also I have understood. But what is exactly S, AQ, and then there is a arrow sign which is shown upward. What does this exactly mean? Okay, so I will explain you what exactly this means. If a gaseous product is formed, okay, that is gaseous product is formed, then instead of writing G, we show it with an upward arrow, that is an arrow which is pointing upwards. Okay, that means you can see that in the right hand side there is a formation of H2. That means your H2 is releasing outside, that means it's a gas. So instead of writing G below, you show it with a upward arrow. And if a product is insoluble solid, that is in the form of a precipitate, then instead of writing solid or S, we can indicate it with a arrow pointing downwards. So now in this example, you don't have any precipitate showing arrow. So whenever in any example, if you see that your product is a precipitate, that is formation of a new bond which is a precipitate, you show it with a downward arrow. Okay, but in this example you can see that your hydrogen is a gaseous product, so you showed it with the upward arrow. Going to the next slide. When heat is to be given from outside to bring about a reaction, it is indicated by the sign delta written above the arrow that indicates the direction of the reaction. So please make a note of these 2 points which are really important. First point is that whenever in the product, if there is a gaseous product which is formed, then it is shown by a downwards arrow. But if there is a formation of a new product which is a precipitate, then it is shown by a downwards arrow. So for the gas you have upward arrow, and for the precipitate you have downward arrow. Please recreate the error that I made. I will repeat it again. Okay. For the gas you have upward arrow, and for the precipitate you have downward arrow. Please make a note of it. Next point that is really important, that is that in a reaction where heat is given from outside, you have to show a delta. Delta means a triangular sign which should be written above the arrow, which indicates the direction of the reaction, which indicates that the heat is being provided from the outside. Similarly, when heat is released during the reaction, it denotes plus heat in the product side. So please make a note of these 4 points. First point is that whenever a gaseous product is formed, you have to make an arrow in the product side which is pointing upwards. When there is an insoluble solid that is in the form of a precipitate, then you have to show an arrow which is pointing downwards. When heat is provided from outside, you have to represent it by a delta sign which is written on the above of the arrow. Okay, and when the heat is released in the product side, you have to write it with plus heat in the product side. Now next, there is an example. Okay, 2S2O which is gaseous plus O2 which is gaseous, which is forming a product of 2SO3 which is gaseous. Now what is V2O5? V2O5 is a catalyst. Okay. Now reaction condition pressure of 2 bar and temperature of 720 Kelvin is given. Certain chemical reactions occur at a particular physical conditions, like there are temperature or pressure or some catalyst is added for the reaction to move on faster. Catalyst is basically to make the reaction faster. These conditions are indicated above or below the arrow indicating the direction of the reaction. This point is also one of the important point. Here V2O5 is the catalyst. As I said that V2O5 is the catalyst that helps move the reaction forward, and the physical conditions required for this reaction to occur are pressure of 2 bar and temperature of 720 Kelvin. Special information or names of reactants / products are written below their formula. Now for example, as I said that there are some states that you have to write of the reaction, that is whether it is solid or aqueous or liquid, then all those things, all those special information, or if the reaction is concentrated or dilute, whatever it is, you have to write it below the formula because you have to indicate that what exactly it means. Here, the copper metal is reacted with concentrated nitric acid to give reddish colored poisonous nitrogen dioxide gas. Now, balancing a chemical equation. If the number of atoms of the elements on the reactant side of the equation is same as the number of atoms of those elements in the product side, then the equation is called a balanced equation. Very important for your 10th standard syllabus, balancing a chemical equation. This exactly means that your reactant means your left hand side, right? So your left hand side atoms should be equal to the right hand side atoms. Only this much is given in this definition. So whenever you're writing a definition, you make sure that you have certain tips and tricks to imagine or to remember the definition, because you will have many definition which will make you difficult to understand and remember the definition. So you should understand that when there is number of atoms of the elements on the reactant side, that is in the left hand side, it should be equal to the number of atoms in the right hand side, that is in your product side. This is called as balanced equation. Now, in any reaction, the total mass of each of the elements in the reactant is same as the total mass of each of the respective elements in the products. This is the law of conservation of mass which is used in balancing a chemical equation. Now let's learn what are the steps in balancing a chemical equation. This is literally very interesting, but it is equally important and it is asked for 3 or 4 marks in your examination. So please pay attention to this. A chemical equation is balanced step by step. A trial and error method is used for the purpose. Whenever a chemist or any person who does experiments, there are always trial and error method. So at the same time, even we will make certain trial and error method to understand a chemical equation, that how it is balanced step by step. Let's consider the first example. Iron, when reacted with steam, gives ferric oxide and hydrogen gas is liberated. Write the chemical equation from the given step. Now this is your step 1, where you write your chemical equation as it is from the given reaction. Fe, which is in the solid state, plus H2O, which is in the gaseous state, will form a new product which is Fe3O4 plus H2, which is in the gaseous state. Now, step 2. Check whether the equation is balanced or not by comparing the number of atoms of the various elements present on both sides of the equation. So here you have to check whether the equation is balanced or not by seeing that the atoms on both the sides are equal or no. The number of atoms of all the elements on both sides of equation are not same. It means that the chemical equation is not balanced. Okay. Now, step 3. It is convenient to start balancing an equation from the compound which contains the maximum number of elements or the maximum number of atoms. Now, in this example, you can see that iron has the maximum number of atoms, correct? So in this equation, for balancing, as the number of atoms of Fe in the equation is unequal on both the sides of the equation, we will multiply Fe, that is iron, by the factor of 3 to balance the number of atoms. The resulting equation will be 3Fe plus H2O, that gives you Fe3O4 plus H2, which is given out. Now you make a table and see that ferrous, that is iron. Okay, much precisely you can say it is iron, which has 3 reactants and 3 products, that is 3 number of atoms in the reactants and 3 number of atoms in the product side. But oxygen is still unbalanced, but hydrogen got balanced while you are balancing iron. Now to go further, we will use the same method as above to balance the unbalanced atoms of oxygen, because oxygen wasn't balanced in the last step. So when you balance the oxygen, you get that 4 atoms of oxygen is there on both the sides. We will check whether the above equation is completely balanced or not. Now you can see that the equation was not balanced. So here we are multiplying 4 to the whole water. So the number of hydrogen atoms on reactant side will be 8. Now in the last step you observed that hydrogen was balanced and iron was balanced. But in this step, when you balanced oxygen, again hydrogen became unbalanced. So to balance the hydrogen gas now on the product side, we will multiply with the factor of 4. When you multiply, we will check that the whole equation is now balanced and the number of atoms of iron, oxygen and hydrogen is balanced on reactants and products. That means they are equal. Now step 4 is to write down the final balanced equation. In this way, a balanced equation is obtained from an unbalanced equation by applying proper factors or by multiplying with certain numbers which are suitable to balance this complete reaction. Now again, by taking one example, I will again make you understand what is balancing of a chemical equation. Nitrogen gas. When reacted with hydrogen gas under high temperature and pressure, it creates ammonia gas using iron as the catalyst. Now here the step 1 is to write the chemical equation as it is. Here there are certain physical conditions. Okay, take a note of this. 150 to 200 atm, 450 to 500 degrees Celsius and Fe as catalyst. Now in the step 2, as you know that you have to make a table of reactants and products of the elements that are there in the reaction. Now you have nitrogen and hydrogen. So see how many atoms are there on the left hand side and see how many atoms are there on the right hand side. You can see that they are unequal. So what you do is you take a factor or you select ammonia because that has the maximum number of atoms, right? As I told you in the last example, you have to take the first molecule or first atom which has the maximum number of atoms. Okay, so select N for balancing as the number of atoms. See whether it is unequal or equal on both sides. If it is unequal as it is shown in this reaction, then multiply it with a factor of 2 which will balance the equation. You check whether it is balanced or no. Now you can see that nitrogen is completely balanced, but you can see that hydrogen is still not balanced. So to balance hydrogen, you multiply it with factor of 3 because you want 3 more atoms to balance in the product side, that is 6. Okay, so that means 2 into 3 will give you 6. So that means 6 atoms on the left hand side and 6 atoms on the right hand side. Now your equation is completely balanced. So in the step 4, you write the final balanced equation and you are done. So there is one more example, which is example 3, which is of phosphoric acid is reacted with HCl, which gives you phosphorus pentachloride and water. Here also same in the step 1. What will you do in the step 1? Discuss it with your friends. Step 1, you will do write the reaction as it is. Step 2, make the table of reactants and products of each elements. See which is balanced and see which is not balanced. In the third step, you take the maximum number of atoms. Which has the maximum number of atoms? Yes, you are correct. Hydrochloric acid, that is HCl, has the maximum number of atoms. So you will multiply it with 5. You will check whether it is balanced or no. You will see that phosphorus is balanced, chloride is balanced, chlorine is balanced basically, but oxygen and hydrogen is yet not balanced. So you will balance the water with multiplying it by 4. Check again that whether it is balanced or no. Now you can see that the equation is completely balanced. So in the step 4 you write the entire equation and you get this. Now for your homework and for your reference, I want you to solve certain example of chemical equation and do your exercise questions thoroughly. This will be maybe more than enough for you to score a better marks in your examination. I hope this presentation has helped you in a better way. There are answers at the last, but I do not want you all to cheat. You all write the questions, write the answers, and then at the last you check the answers whether it is correct or no. It's a great achievement if you get a good answer, but if you don't, then try. There are so many examples, and I hope this is a very helpful video for all of you. Thank you.